Hello, I'm Jack Rickard with Electric Vehicle Television. Today we're going to present an instructional video on how to upgrade the software in our Generalized Electric Vehicle Control Unit, or JEVCU. The JEVCU, a history of it, might be in order. Let me get a couple of things arranged here. In November of 2012, we acquired a large number of Siemens 1PV5133 AC induction motors from the liquidation bankruptcy auction of a company called Azure Dynamics. Azure Dynamics had developed a E-Transit Connect, a light van, electric driven for Ford Motor Company. And they were kind of a high flyer for a while, but eventually the dogs got them. They went bankrupt, and an auction was held of their assets. We picked up 65 of these motors, along with 50, I think, originally, of the what they called the DMOC 645 digital motor controller. We eventually picked up another 10 from individuals and so forth of these controllers. And subsequent to all that, Siemens had been stuck with over 100 of the motors designed specifically for this project that they were unable to dispose of. And we acquired those. And so we have a large number of motors and controllers to sell to our viewers, which is kind of an interesting play on our part, since there's no way to use them. The DMOC 645 used in the Azure Dynamics had all of the software and inputs removed, where you could enter throttle voltages, brake voltages, and various signals to control the inverter to drive the motor. And in fact, the only way to drive it with the firmware that was available in it was by CAN message. CAN is the Controller Area Network Protocol developed by Bosch in 1987 to try to minimize the raw poundage of copper wire that was growing in automobiles as so many new features and electronics were added. And it's proven a very popular strategy. Today, almost all new cars have not only a CAN network, but often 3 or 4 of them. The Chevy Volt has 104 multi-controllers in the car, all talking to each other over CAN, for example. This has caused kind of an interesting thing. These inverters and motors that you see are somewhat commoditized. They're kind of generic. The concept is the original equipment manufacturer, automotive manufacturers, want to be able to take any motor and any inverter, but particularly ones that perhaps they manufacture, and drop it in any model car with no changes to the motor or the inverter. And so they make them somewhat generic, and then they install a device called a vehicle control unit. Normally, sometimes an ECU or engine control unit, but vehicle control unit, which is a little computer, a multi-controller with software written specifically for that vehicle. And it manages all the vehicle systems. It's the brains of the car. And it gets the inputs from the throttle and from the brake and from the ignition key and from the gear selector and so forth, and makes intelligent decisions as to what CAN protocol message to send to the generic inverter and motor to drive the car. And some of the brains, or the unique aspects of the vehicle, are held in software in this small, inexpensive vehicle control unit. And that enables them to drop in any motor and controller, and with a few changes to the software, work with the same car. It's actually kind of an interesting development. But we didn't have a VCU. And worse, we don't have a car model. We have a bunch of people making a bunch of different vehicles electric. And in fact, they have a variety of throttles and accelerators and a variety of brakes and a wide variety of needs and wants as to what they want this inverter and motor to do. And the key element of the VCU is that it's in software and it's considered proprietary by the manufacturer. In fact, if they need to change or upgrade it for that particular vehicle, they issue a recall and have all the people that have the vehicle bring it into the dealer and flash new software in it to make the changes. And there are no configurable items in it that even can be made at the dealership, much less by the end user. If you want more regenerative braking or less regenerative braking, don't want it on the throttle or do want it on the throttle, you kind of have to buy a car that's set up that way. You don't get to change any of that. For individuals building their own electric cars, and for the university alternate energy programs that we've become very popular with, and prototypers, people who are working on a prototype of a vehicle they'd like to get funding for and develop and sell. And that's our viewership, and that's where our components go to. But they want to be able to change everything. And so we decided to launch a program to develop what we call the Generalized Electric Vehicle Control Unit, where it had an interface where you could actually change many of the variables that you want to change, what the voltage is on the throttle input that you want to control the thing, and how much regenerative braking, and how the brake connects, and how to turn on the brake lights, and pre-charge the unit, and many other basic configuration items without doing any software programming at all. And so we developed the JEVCU to do just that, to provide two interfaces, one by wireless website and another with a basic USB serial port command interface, where you can make changes to the crucial variables determining vehicle operation and kind of tune your inverter and controller to the specific vehicle application you had. We originally bought 65 of the motors and 50, I think, of the DMOC 645s. The motors are made by Siemens, and in fact, they had a stockpile of another 100 ready for delivery to Azure Dynamics, and they were kind of stuck with them because Azure Dynamics went broke. So we bought those too, so that brought us to 165 motors. The trick is the DMOC 645 was made by Azure Dynamics, who is now corporately deceased, and there will be no more made. It's extinct. Once we sell out of those, we have no more. And so for the last year, we've been scrambling around trying to get other inverter manufacturers to do the necessary fine-tuning or characterization of their inverters to the Siemens 1PV5133 motor. We've had some modest success. Reinhardt Motion Systems has characterized their line of inverters to the Siemens. Scott Osborne in New Zealand, we've just received our first Scott drive. This is a 150 kilowatt AC three-phase inverter that will operate the Siemens, and we're talking pretty seriously with GEVCU. They have a new Gen 4 series, Generation 4, Series 8, and Series 10 inverters that are pretty strong and could potentially drive this. And so the Generalized Electric Vehicle Control Unit will kind of allow all this to live on, and for us to use those remaining motors with a variety of inverters. It goes quite beyond that. We're working on a module, for example, for the UQ and Power Phase 10, and I required 10 drivetrains, those from the Coda bankruptcy. And that sort of opens your eyes to sort of the future. This is how the OEMs make electric cars. They all use AC systems, and they're kind of generic, and they deal with it with a VCU. So if we can get the Generalized Electric Vehicle Control Unit, if we can do a module to do CAN messages for the Nissan Leaf inverter, you would be able to use salvaged motors and inverters from the Nissan Leaf to electric car project. Potentially the drivetrain from the Model S. They wreck those too. And the Chevy Spark and the Chevy Volt, the BMW i3, and the list goes on. We think JEVCU could be the can opener to allow us access to a cornucopia of future drivetrain components that are fallouts from the electric vehicle, the original equipment manufacturers or automakers' efforts to build electric cars. And so it's kind of important. The JEVCU is based on the Arduino DUI. This is an inexpensive educational platform. I quite like their little integrated design environment. It's C++ is where they do the software, but it installs on Linux or Windows or Macintosh quite easily. It's a simple interface and a simple IDE. It doesn't do what a lot of people want to do with a software development thing, but it's simple and it's easy to learn. And the Arduino DUI came out about the same time that we announced the JEVCU project. And this is a very capable 84 megahertz ARM3 Cortex multi-controller that's several orders of magnitude faster and more capable 32-bit system compared to the Arduino's previous 8-bit 16 megahertz type controllers. And better yet, the chip itself supports 2 CAN bus channels. And so we have taken that and done our own board with one USB port and brought it out to this amp seal 35 connector and hardened it and made it put some DC to DC converters in it, clean up the power supply thing where it's suitable to work in an automotive environment. With a more limited set of inputs, we can do 4 analog inputs and 4 digital inputs and 8 digital or analog outputs. And so it's sort of a limited set of Arduino. Unfortunately, there's no easy way to update the software in it. There's no binary flashing procedure for it. I can't send you a file and have you update it. So we've sold quite a few JEVCUs and continue to do so, but we also continue with the software. Now, you may not need a module to drive the UQM or the Reinhardt in your JEVCU if you have a Siemens motor and a DMOX 645. But we continue to improve the software in other ways, too. And we've made the web interface a little more informative and interactive, and added features to drive cooling fans based on temperature, to drive brake lights based on regenerative braking, pre-charge procedures to run a couple of relays to pre-charge your DMUX 645 or other inverter. And so we continue to work on the software. Sooner or later, you're going to want to update that software. And so I'm trying to make a rational procedure that's doable, if non-trivial, to do that. You don't have to do any C++ coding, but you do have to be able to point to the software and click the compile button and to flash the JEVCU Arduino DUI processor. A little bit further complicated, and there's actually two processors in the JEVCU. In order to have that wireless web page interface and not interfere or take away from our main controller operation, which is to drive the inverter, there's a second processor in the box. A Connect One module that handles all the wireless and all the web, and that holds a image of a website that we actually upload wirelessly to that module. And so when we update the software, it's often there's also a upgrade to the website interface because of new variables that you can change in that interface. So we're going to have a procedure on how to reflash that web image into the Connect One. So let's get started. The first thing I think we probably ought to do, well, the first thing is I'm going to give you a shot of what I see out the bedroom window here. And let's see if I can get that going. And there's the Mississippi River. We're having kind of a cloudy, rainy day here. But let's get started. We're going to do break this into a couple of pieces. One is we're going to download and install the Arduino software. We're going to, second, make sure you have the correct libraries in the Arduino to operate the JEVCU software. We're going to download the JEVCU software and compile it. And then we're going to flash the Connect One module with a new website image. And that's kind of the procedure to get your JEVCU up to the latest in software, in case that's the thing you would want to do. Stay with us. Okay, the first thing we're going to do here on our Mac desktop is I've got a browser already set up to let's see if I can make that a little bigger. Go to arduino.cc/en/main/software, or simply Google it, Arduino, and go to software downloads. And you get the screen where you download the Arduino software. With Arduino IDE, version 1.05 is the one for the basic Arduino. We want the 1.5.6. R2 right now has support for Arduino Uno and Arduino DUI boards, and we're an Arduino DUI board. Here's the problem. We have different ones. Here's a Windows installer or Windows zip file, Mac OS X, Linux 32 or 64-bit, and the source code where you can actually compile your own version. We would use the Mac OS X. You may use other ones. It's really pretty straightforward how to do it, and it actually contains instructions. The Mac OS X is so simple. You simply download it, and if we go to our downloads area, we'll see I've done several versions here. There's the one that's downloading now, 369 MB, but it's already an app. I can simply copy this into my applications directory or onto my dock, and I have an Arduino. And so the Windows is perhaps a little more involved, but not much. the Linux. Of course, you have an install procedure. But they're all pretty straightforward, and the first thing you want to do is locate and download this software from Arduino, which is what allows us to deal with Arduino software. It also has a serial port terminal program, which a lot of the operating systems no longer ship with an old style terminal program, but you'll need this to go out through the serial port to make changes to your JEVCU anyway. And while any serial port terminal program will work, the new Windows doesn't even ship with a free terminal program anymore. They used to have HyperTerm. They don't anymore. And similarly the Apple. So Arduino, their interface, gives you a serial terminal program that you can use to communicate with the JEVCU quite capably, and it's pretty simple. So that's the download of the Arduino software. Okay, let's talk a little bit about JEVCU libraries. Arduino has a concept called libraries where you can extend essentially the Arduino program. This is a way for individuals to make objects into libraries that can then, the function of those objects can be called from any Arduino program. And we have 4 libraries that we have to have in order for Arduino to do these. One derives from Brazil. The other 3 were written by Colin Kidder and are available at GitHub/Colin80 in the latest version. However, that complicates things a little bit. Here we have our EVTV site, and we're going to start there. Go to the online store, and let's go to motors and controllers. And if we scroll down, we'll find the JEVCU. This is where you buy it. Of course, we want you to buy it. If we click on that, we go to the detailed screen. Here's a description of the JEVCU for shoppers. But here are 3 very important links that we keep updated. The first is the JEVCU user manual. This is a large PDF file which describes how to use JEVCU. JEVCU, the latest software, and I can just drop a copy of the latest software into our Amazon repository, and this link points to it, so it'll always have the latest available software we've done. The third link is JEVCU libraries needed to compile JEVCU software. We've simply pulled them together here so it's simple for you to locate them and add them to your Arduino system. If I click on that, of course it downloads. And if I bring up my Finder and the Mac, here's JEVCU libraries. It's a compressed zip function you'll find on Windows. Here are 4 required libraries. DEWI CAN, written by Colin Kidder, that lets us do CAN bus communications. DEWI RTC is another Colin Kidder library for real-time clocks. I'm not sure what we use that for. DEWI Wire is kind of important. It's a new version of the wire library done by Colin Kidder so that we can access an EEPROM chip we've added to the Arduino. Arduino DEWI has no EEPROM, oddly, and so we can't really save things. So we've added the chip, and DEWI Wire lets us access that. DEWI Timer is done by a Brazilian kid who, there's a number of hardware timers, clocks in the DEWI that are virtually unused by the Arduino software. There's actually 3 clocks, and they each have 3 interrupts, giving us 9 timers. We use these timers to generate different ticks at different rates, and different modules in JEVCU are then activated by timer interrupt. So we have our main program loop that repeats, but individual items in JEVCU, individual objects, can exist outside of that loop and activate and run with a handle tick routine that is generated kind of like a hardware interrupt, but it's really a timer interrupt. And this is all enabled by this Dewey timer library. It gives us almost a real-time operating system type thing. I'm going to copy these folders here with a Control-C. And we're going to go to the Mac library repository, and that's under Documents. And in Documents, you'll have an Arduino folder. And under that, you'll have a Libraries folder, among other things. And right now, I've got that emptied out just to show you, but I select Libraries, and I can do a Command-V, and my 4 libraries, those folders go right into Libraries. These are now available to any Arduino program I happen to be working on, and I can include these in the software with include statements and then call functions out of them. And so, for your purposes, if you download the JEVCU software and compile it, you have to have these 4 libraries in your libraries directory, or it will not correctly compile. And so that is the addition of the libraries, and that's pretty much all there is to that. This will be a different directory, of course, in Windows, but not very different. It's, again, Documents, Arduino's Libraries, but under your username. And so it's important to get these libraries and to get them available to Arduino, or you will fail in compiling the new software and uploading it to the JEVCU. Okay, now let's talk about getting the JEVCU software itself. Again, I'm at the EVTV website. I'm going to go to the online store again. And let's go back into Motors and Controllers. Scroll down to the JEVCU. And go to the detail page on it. As I pointed out, JEVCU, the latest software, is under this link. We simply click on it, and that downloads to our downloads area. Let's bring up Finder in the Mac and look for downloads. And we're down here for earlier, and it says JEVCU 402. And that is my new program file. And it's okay for it to be right there or anywhere you want it to be. It is a folder named JEVCU 402, which is kind of a version number. Within it, it has a lot of files, some directories. The main program that you want to load with your Arduino environment is JEVCU402.ino. It'll be the same name as the folder. If this goes to 404, it'll be JEVCU404.ino. Let me point out that there is a website folder here. And if we look in there, we see a source directory. This is actually the source files for the website. But if you change those, it does nothing. You have to have a special program to compact those into a compressed image. And we've already done that for you, and it's called website.img. And that's what we upload to the JEVCU box, the on Connect One website. And so JEVCU 402 is our program. And that's the download of the JEVCU program. Okay, let's bring up Arduino and see if we can get all this to work and walk you through a couple of functions of that. I'm going to bring up Finder. I'm going to go to my desktop where I have a Arduino app, and I'll start that. And that gives me an Arduino screen. Let me close these things and we'll open fresh. I've got Arduino. Here's my menus up here. Here is a sketch called multi-serial. I don't know if I can... I'll have to quit to do that. I don't want to do that. I'm going to open a file, and I'm going to say open. I'm going to go to desktop, JEVCU 402, and select JEVCU 402.ino, which is the same name as the a directory, but with the .ino. That's our main program file. There's a lot of software individual object files in here, but this is our main file that we want to open, and that gets us a screen here that we can see our software. You don't want to make any changes to this. You don't have to know what it says. We're going to do a couple other things and then compile it to our system. The first thing we're going to select is our type of board. We go to Tools menu, and it says Board. And if we click on that, we get a list of different kinds of Arduino boards. And at the bottom, it has Arduino ARM 32-bit boards, and it has Arduino DUI programming port, and Arduino DUI native USB port. The Arduino DUI actually has two different USB ports, and you can use either of them to program it. The JEVCU does not. It has one USB port. We had no reason to have a second, so we didn't include it. And that's called the native USB port. It's actually the USB port that goes directly to the multi-controller chip. And so you want to select that as your board, or we're not going to be able to do anything correctly. And then we want to go to port. Port is where you select your serial port. Now, I don't really know what to tell you on this. On the Macintosh, it's kind of like Linux. You have devices directory and different devices. We know we're not talking to it by Bluetooth, so those four are out. That leaves us device TTY USB modem 20231 or device CU USB modem 20231. Either of those actually works fine and will be the USB connection. Now, in order for these to appear, you have to have connected your JEVCU to your Mac with a USB port, or these will not show up on the screen. They won't be in the list. Let me disconnect my box here, and let's go back and see what we get for ports now. If I go to Tools, Port, they're all Bluetooth. My two ports went away, and so this is one of the ways you can kind of tell on either the Windows or the Mac, is to bring up your ports and see what you got, and then make that go away. And let's plug in our printer cable, which is included with your JEVCU, from any USB port on your PC to the JEVCU port. And now when I go to Tools and I go to Port, I've got two new entries here, and they're both USB modem, and either one of them will work just fine. And so that's kind of the thing. I told you that there was a serial terminal program in the Arduino. I mean, it's not really to compile anything or deal with software. They call it a serial monitor, and it simply brings up a serial screen. We want to set that to 115,200 baud, which is not precisely correct, but that's what they call it. And you can pick any of the various ones. Here it is. If you'll notice up on the screen, I've got a series of dots that are coming across. That's simply the JEVCU heartbeat. If I go up here and enter an H and return, I get a whole screen full of stuff. I've got auto scroll on, so every time I get a dot, it jumps. I'll turn that off. And here is our build number, our motor controller status. It's running, it's faulted not. System menu, these are short one key commands like the H that I just used to display this message. Then I've got some config commands. These are, I put in this command log level equals 1, and that sets it to 1. Systype equals 4, etc. All these are different variables you can set on the Arduino to affect the operation of the control, and they are kind of ugly mirrors of variables that you have access to with the website that you get on wirelessly. So there's two ways to set up your JEVCU, and one is just call this up and enter. Here's T1 min, that's your throttle 1 minimum value is 85. That's just a value that shows up on our JEVCU when we haven't pressed the throttle. And T2 minimum and maximum I have set to 0. We don't have a second throttle input on this particular application. You may have. And these are regens and mapping, and that's all kind of described in the book, the PDF on the JEVCU, what these are. Admittedly, this is kind of an ugly way to do it, but it's actually a quick and simple way. I often do that rather than get on the website, but most of you will probably use the website to set. But understand, these are the same variables you are setting if you set it on the website, and then come pull up the menu. The change will appear on this menu, and so we know we're connected to the JEVCU because we've got pulled up our serial terminal and gotten the menu, so we're okay. We've got this open, and this is our latest software. And what we were looking at was a serial monitor of the software running that's in the JEVCU now. That's what's running there, and we ship it to you with software in it, so you always have this. But we want to upgrade this to newer software, and so we've downloaded JEVCU 402 and brought it up at Arduino. And we have selected our board and our port and used the serial monitor to determine that we are indeed connected to the JEVCU. This is a verify. It simply does a compile but doesn't upload it, this check mark. The right arrow is upload, but it actually does compile the software when it uploads. And we're going to click that. And you'll see this window down here, which we can even expand if you'd like to see. This is what's going on behind the machine in your PC to compile the various modules of the JEVCU software. And it's a little bit of a process, sort of indecipherable things here. And then we get to the end, and what we're looking for here is CPU reset. And what that means is that we have completed, there's no error messages, and it's reset the JEVCU. It's uploaded compiled the software, uploaded it to the JEVCU, and it has restarted the JEVCU with this CPU reset. So now I can go up in my tools and serial monitor, and if I had a different version, I should have updated this, but I may not have. And so we're now running the new software. And so that's an operating JEVCU. That's really all there is to taking this new software, making sure we have a connection to the board by selecting the right board and the right port, verifying that it's operating with our serial monitor, and then simply clicking this arrow. And if we culminate with no errors and get a CPU reset, we have compiled the software, uploaded the binary to the JEVCU, and reset the JEVCU. Now, if you get anything else, any kind of error, it's simply not something you're going to get unless you don't have those libraries in there correctly. And so you have to have those libraries, and they have to be at a place where your Arduino program can get to it. And so that is the process for uploading a new version of software to the JEVCU, and that's pretty much complete. Okay, I mentioned we were going to talk about the website interface to the JEVCU. There's a couple things we have to do that. First one, I'm going to go up here to my wireless section, and you'll see that it has several selections, River House and River 5 megahertz. Those are two normal APs I have in here, and then there is JEVCU, and that's the one I have selected. And you have to make this selection in order to be able to access the website, and it will come up, and it'll appear on your scan as this, all caps, JEVCU. And you have to make that connection with your wireless, which means you usually kind of lose your connection to your other AP while you're accessing the website, and that's okay. Let's see, what have I done with my here's my Safari and the store. What I'm going to do now is enter a IP number, and this is the only way you can do this: 192.168.3.10. Now, we should have a tricky little name or a JEVCU or something. Unfortunately, that's not the way it works. You have to enter the IP number of the board, and we've selected .3.10. That's actually kind of the default on this Connect 1 module. And here is our JEVCU version 402 that we just uploaded. And here's our pre-charge relay, our main contactor output we're running. We don't have a lot else because we're not hooked up to a DMOC and getting information from it. But, I can show you something here. Let's disconnect the JEVCU and plug it back in. And we should automatically pick it back up when it comes online. And here I am at 8 seconds. I have my pre-charge relay and my output 0 activated, and at 14 seconds the main contactor and output comes on. We can see we're running. So these enunciators give you kind of what's going on here, which of your outputs are on or off, whether you're running or ready, over temp inverter, an error, a warning, that sort of thing, and displays certain things. These are all empty because we're not getting the data for motor temp and inverter temp from the DMOC 645. It's not hooked up. We're not getting our requested torque or our actual torque because we don't have a throttle hooked up. We don't have the DMOC 645. That's our status window. This is kind of interesting. It's our dashboard when we are hooked up. And you can do this with a smartphone or an iPad tablet. And if you connect your iPad to the JEVCU network and go to 192.168.3.10 in Safari, you're going to pull up the screen, and you can do it while you're driving down the road. And when you're doing that, you will actually display live data on what your throttle percent is, how much torque you're making at any one time. Negative for regen, green will be positive torque. The DC current, negative during regen and positive when you're driving. Your RPM of your motor, the motor temperature in real time, the inverter temperature in real time, your pack voltage in real time. This is actually kilowatts, the amount of power, the voltage times the current instantaneously. And this will keep track of your kilowatt hours, how much energy you've taken out of your pack. That value is actually cumulative each time you start the car, and it'll save it to EEPROM, and so you can start and stop a dozen times, and this value will just keep going on up. but it resets. You have a voltage you can enter that's your fully charged voltage. Then after you charge the battery pack and you get in, if the voltage is above this value, this will reset to 0. And you set it at some high value that it immediately falls off of when you start to drive. Here is our configuration screen, the main thing, and this is our throttle diagram. We've selected one pot and have a minimum and maximum signal level that we have determined experimentally from our throttle. The other throttle settings are off. We're not using any creep value of torque like an automatic transmission. The throttle type can be linear or inverse or unknown. We're going to put linear. What that's respecting is whether your second throttle goes from 0 to positive, the same as the first throttle, or whether the first throttle goes 0 to 5 volts, and the second throttle might go from 4 volts down to 2 volts, inverse, and so we can accommodate that. This is some sliders that are actually very important, and you can tune endlessly to change the way your vehicle feels. The first one is pedal position for regen maximum. And if we look down here, we have a map of our throttle. At 0% throttle, we have no regen. At 4%, we have our maximum regen level. And I can actually move that around with this slider here. And here I'll set it at 2% maybe. And the second is our pedal position for regen minimum. And that is here. And so right now at 27%, let's say I want to make that 25%. This is at 25% we have minimum regen. Now when we start up, there is no regen. We're sitting there. The wheels aren't turning. So we won't get any forward motion until this value, 29% of the throttle, at which point our forward motion starts. So the first 29% of our throttle, nothing happens. And that dead space is very common even in an internal combustion engine car. At 29% we start and we go to 100% of our available torque here at 100%. This point here is pedal position 50% throttle. And I can adjust that anywhere I want. Let's say I want to put it at 75%. Why would I want to do that? Well, what that does is stretch out the first 50% of my torque from 29% of throttle to 75%. And that's almost 50% of my actual throttle throw is devoted to the first half of the torque. The second 50% of the torque happens from 75 to 100%. Now, why would I want to do that? Well, from half of my torque to full torque, you're talking about putting the pedal to the metal. And so I don't need a very fine control here. I'm either stepping on it or I'm not. But on the first 50% of the torque, by stretching it out over 50% of my throttle throw, I get a much finer level of control, like in the parking lot and at slow speeds, because I've mapped this torque from 0 to 100% torque to where 50% of it happens in 3/4 of the throw of the pedal. And so I've stretched it out, if you will, where I get better control in here. And when I'm going from half throttle to full throttle, it's sort of compressed down here. I don't really need a whole lot of differentiation. So that's a way to tune it. This value here, we can overlap these, or we can't really overlap them, but we can connect them. I've left a little gap here from 25 to 29%. What would that be for? Well, there I get no torque. I don't get regen, and I don't get forward torque. And as you can see, this is labeled coast. If I can find that notch, I can just free roll and not use any energy, not make any energy, and the car will just roll on and on and on and on. So I like having this little coast notch in there. Here's our brake values. Again, this is just signal level values we determine experimentally. And the amount of regen that we use on the brake. If I take my foot off of the throttle completely, I have no regen. And our minimum brake regen is at 0%. You probably want to keep that at 0%. Otherwise, your brake is kind of always trying to put regen in it, and it keeps us from turning the motor. But then at maximum brake regen, which is our maximum signal level, and we can set this kind of anywhere, I can have 50% regen, or I can have a higher value or a lower value. And so this lets me tune my brake regen where I have a very nice feel of almost like power brakes, but I'm not throwing myself through the windshield or not having any. Here's some other important variables. This is the max RPM of the motor, and we can go up to 10,000 RPM with this Siemens motor. So here we've got maximum torque. I have that set for 300 newton meters right now. 220 foot-pounds. That's about the maximum Siemens motor with a DMAX 645 will do. Why would I want that as a variable? Well, let's set it at 50 newton meters. So, let's say I'm not too confident in my throttle and brake settings, and so I'm going to set this to 50 and save it, and that's going to limit the amount of torque that the motor can make at all, and that might keep me from throwing the VW thing through the back wall of our facility because I didn't have the throttle adjusted to my liking. So you might set a lower value while you're experimenting, and then go back and put it up to 300 later. You can put it to 3,000 for all I care, but the DMAC is only going to set a certain amount. Log level is set to info. We've got debug info warning error off. I wouldn't worry about this too much. I wouldn't put it to debug, but it's about what appears on the serial port while the program's running, and we use it to debug the software. Battery voltage, 330 volts DC. I've got 160 amp hour cells in the thing. When I get done charging it, it'll be about 334 volts. Right after charging it, it might be 350 volts. But if I get in the car and turn the ignition key on and back it out of the shop and start down the road, it's going to drop below 330 quite quickly. Now, for the first block or so, anytime it goes above 330, we're going to reset that kilowatt hour meter. But within a block, we're going to be safely below 330. The only time it'll go above the 330 level would be during regen, and actually we don't reset the kilowatt hour meter on voltage spikes if there's any regen going on at all. Our pre-charge relay can be none or 0 through 7. This is the output of the JEVCU that we use to engage a pre-charge relay. Here's our pre-charge delay. We're going to turn that relay on, and after this amount of time, we're going to turn our main contactor relay on. And it's got to be a different output than the pre-charge, but it too can be any of them. We can set these to none. In some cases, your inverter may take care of pre-charge by itself, and so you don't need to do this. The pre-charge delay is simply amount of time that we're going to let it pre-charge through a resistor before doing the main contactor, and it's in milliseconds. So 13,000 milliseconds is 13 seconds. And these are test values, so I can watch it on the screen as I showed you on the status screen. In real life, you might set this to 500 milliseconds, or 1,000 for a 1 second delay, or 1,500 for a 1.5 second delay. You don't need 13 seconds to do pre-charge. Here's our cooling fan relay. This again is one of our 8 outputs, a switched MOSFET output that we can use to switch a relay and turn on our cooling fans on our heat exchangers. And if you recall, we actually, on our dashboard, also had temperature gauges for the motor and the inverter. The more critical of those is the inverter. The DMOX 645 cuts out at 80 degrees centigrade. It doesn't shut off, but it starts current limiting. And so I've got this set to at 70 degrees centigrade. This cooling fan relay output, number 7, is going to go on. It's going to switch on the MOSFET, engage the cooling fan relay, and turn on my cooling fans. Now I have a cool off temperature too, in this case 62 degrees centigrade. Well, I don't want it, if it hits 70 and I turn on the fans and the fans work and it comes down to 69, then it'll turn off. But I'm still driving the car, and a few seconds later it's back to 70 again. So all these fans going on and off very rapidly. Well, we don't need that. Let's leave it on once it hits 70 until it gets down to 62 and take out the hysteresis there. And when it gets all the way down to 62, then I'll cut off that output and turn off my fans. And now if it heats back up to 70, which might take several minutes then it'll come back on. So now they'll come on and go off as needed, but on a much slower cycle. And you can set this to whatever you like to moderate that cycle. You may want it to come all the way down to 55 degrees centigrade or something before it turns back off. And so once it hits 70, it's on for quite a while, unless you get down to 55. You can moderate that. Brake line output number 5 is simply we're going to switch on one of our outputs whenever we have more than 10 newton meters of regenerative torque. And this is as we go down the road, if we use our throttle to apply regenerative braking, we're going to slow down quite dramatically. But since our foot's not on the brake, our brake lights don't come on. And so the Mack truck full of gravel behind us does not pick up that we're slowing down because he didn't see any brake lights. And he tries to crawl in the trunk. Well, I don't have that much of a trunk on the VW thing. He's in the car with me. And so by setting this output to 5, tying that to my brake lights, anytime I get above a threshold level of regenerative braking, it'll turn on the brake lights. So if I do a little bit of regen, just a tug, less than 10 newton meters, it's not going to light the brakes. But if it's above 10 newton meters of regenerative torque, it's going to turn on the brake lights. And any changes you make here, you want to click Save, and it's going to require a password, and the password is secret, because we want that password to be a secret. We call it secret, and then that saves it and takes you back to your status screen. About is simply some text about who we are and how great we are, and that is your interface for the JEVCU. To set some of the configuration items and monitor some of the operation. And it's working pretty good at this point. Stay with us. Okay, so that's kind of an overview of our JEVCU web interface, but wait a minute, you were going to show me how to update it. And indeed, when we update the software, we have to update this website. Or we normally would. It would be unusual if we made software changes that didn't involve some change to the website itself. Let me show you a trick again. We are connected to JEVCU as our AP, and we are at 192.168.3-10. But instead of just being at that, I'm going to add a backslash and iChip. ICHIP. I put a capital C, it's not necessary. And we get a whole different screen. This is our Connect One base website. This is the website where we can monitor different parameters and set different parameters about the Connect One device. And the Connect One device will do an amazing number of things aside from a website. But this is basically what we're doing. Here's our serial number, hardware version, firmware version. We can update the firmware on this, but we want to update our user website. And we're going to go down to Files, Upload, and click on this. And they need a password required to change parameter values. And again, we want this password to be secret, so we call it secret, S-E-C-R-E-T. Secret. And so that's our secret password. Now we have various things. Firmware IMZ file to upload. This is where we would upload a new firmware for the Connect One board itself. Modem table, I don't know about that. RPF file to upload, I'm not sure about that. Website to upload, I am sure that is what we need to update here. And so I'm going to go to Choose File, and I'm going to go back to my desktop, to my JEVCU 402, and in that directory, which is where we found our latest software, the JEVCU 402.ino, there's also a directory called Website. Let's click on Website. Here's our source files and a readme.txt, all useless information. Here's our magic thing, website.img. This is a compressed, compacted file that contains all of our HTML and XML files, our JavaScripts, for the JEVCU website. And I'm going to choose that, and amazingly it appears right here, website.img. And now here is a submit button, which is curiously unresponsive. But I'm going to click that one time, and nothing appears to happen at all. But a few minutes later, the file name, it says no file selected. What happened? This is the most idiotic upload function I've ever seen on a device. But we're done. We have uploaded it. Now, all we have to do is reboot our JEVCU and go back to 192.168.3.10, and we get our new website. This works about half the time, believe it or not. About half the time we update a file, it doesn't update at all. The file name stays there. We get kind of a little connect thing over here, and then it times out, and it doesn't even really give us much of an error message. But if the file name does not disappear, we have not successfully updated it. And so often we have to go back and enter iChip again, bring the screen up, go to Files, Upload, give it the password again, select the file again, and submit again. Persistence is your friend here. It's not very good the way they've done it, but eventually you can get it uploaded and updated. And that is pretty much a complete update of a JEVCU. We have downloaded the latest software, downloaded the libraries, installed Arduino, made our connection and checked our serial port, and compiled the new software to it. And then got on wirelessly and seen our web interface. And now we've gone behind the scenes and pulled up the Connect One maintenance screen and clicked on Files Upload and uploaded the latest image on our JEVCU software. Some other tips. We're done, kind of. I want to go back to 192.168.3.10. Recall I said that the JEVCU uses an EEPROM chip. We store many of our variables and configurations, most of them in fact, in that EEPROM chip. Some software changes. Now look here, we've updated a new screen and our throttle's all messed up. Our values are all messed up. What happened? Well, let's reboot our JEVCU. Go to status. Here we're coming up. Now we go to configuration. Well, there it's back. So that's a little bit better. Believe it or not, one of the problems I have, and we've never quite worked out, is if I change this value and save it on a new updated software, often I come on here, I've lost some of these values, and it didn't save the one that I entered, and I have to do it 4 or 5 times in order to get all this stuff restabilized. What happened? Well, the software is looking at EEPROM for these values. We have the old values. We wrote a new value in, and that may have been at a memory location where one of these old values had previously been located. Things moved around in the EEPROM. And so we have to enter all of these, sometimes 2 or 3 times, and save them and reboot the JEVCU and go through that again to sort out that a mapping of EEPROM variables. If we've added variables or subtracted variables from the software and from the web interface. So don't be alarmed if this gets kind of hosed up. You need to know what your basic values are before you do the upgrade, and then you simply keep putting them in and saving them and rebooting the JEVCU, and you'll get it worked out, usually in 1 or 2 effects of that. But what you're doing is we've got the old EEPROM map trying to work with the new software, and the new software we've updated that in flash memory in the controller. We've updated the website in the On Connect, but the EEPROM chip where we had been writing software, we've never changed that. And so we have the values that had been stored, and through various software trickery, we kind of make that fairly persistent because we don't want to lose those variables. But this is working against us on an upgrade. And so sometimes you have to simply enter the values a time or two to get them written into the EEPROM and overwrite the previous EEPROM's variables. And that's kind of a flaw in the system. But that's a little tip on don't be alarmed if your configuration gets a little hosed up on a software upgrade. It's simply a system working its way through the EEPROM permanent memory, where we stash a lot of this stuff where we have the same configuration from one one boot of the system to the next, so they're persistent. That pretty much concludes our software update procedure description for the Generalized Electric Vehicle Control Unit. We hope you found this useful. It's certainly been long and boring, I'm sure, for you, but it's unfortunately a little bit necessary to go through a number of steps to update the software. We want you to be able to always have the latest available. We're excited about JEVCU, primarily because of the new shiny bling drivetrain hardware that it can bring us in the future. And so stay with us, and it's going to be an exciting time getting new bling and new drivetrains for electric vehicles. I'm Jack Rickard for EVTV. We'll see you